Welcome to our discussion of the differences between absolute pressure and gauge pressure. So, gauge pressure is used when you are measuring the pressure of, say, your bicycle tire. If your bicycle tire was flat, then the gauge pressure would be basically zero because there would be no difference between what is outside and what is inside the tire. So the absolute pressure is really the total pressure. All right, but the gauge pressure is not the total pressure. The gauge pressure is really the difference between the absolute pressure, so this is the absolute pressure, and what is out there outside of the tire, which is the atmospheric pressure. So again, the absolute pressure is the gauge pressure plus the atmospheric pressure. If the pressure is greater than what it is outside, the atmospheric pressure, then you have a higher pressure. Like that would be an example of, like, say, something that is blown up, like a bicycle tire. If the pressure is less than the atmospheric pressure, then you have a vacuum. It's like you're sucking something in, and so the pressure is lower than what it is outside. So really, gauge pressure is just really the difference between what is inside and what is outside. Okay, example number 5. We have a solar water heating system. And so there's the solar panels out here, and it's exposed to the air pushing down here. And this is at 1 atmosphere outside. We're asked to find what is the absolute pressure at the top of the tank, and what is the gauge pressure. And by the way, the top of the tank is really right here. Okay, so this is the panels, and then this fluid's going down about 12 meters, and then we're looking for the pressure right there. We want to know what the absolute pressure is and the gauge pressure. So, to find the absolute pressure, we are really just finding the pressure due to the external pressure, PO, plus the pressure that is due to dropping down this fluid. So this is what we call the hydrostatic pressure typically, rho GH. So the pressure in the tank, at the top of that tank right here, is really the external pressure, which is the ATM here. You could rewrite that as PATM plus rho GH. And that is equivalent to 1.013 times 10 to the power of 5 pascals. So that's your external pressure, plus the extra pressure due to this fluid pushing down on the top of the tank. And that's the density of water, which is 1,000 kilograms per meter cubed, times 9.8 meters per second squared, times a depth of 12.0 meters. And this gives you a pressure of about 2.19 times 10 to the power of 5 pascals. This represents the total pressure, or the absolute pressure. So now, the gauge pressure is the amount that the pressure in the tank, or absolute pressure, exceeds the atmospheric pressure. So it's really that pressure in the tank that we just determined minus the atmospheric pressure. So that's really 2.19 times 10 to the power of 5 pascals minus the 1.013 times 10 to the power of 5 pascals. And this gives you a pressure of about 1.18 times 10 to the power of 5 pascals. If you were to convert this to atmospheres, you would have to multiply by an ATM over 1.013 to the power of 5 pascals, which gives you 1.16 atmospheres, or you can also convert that into 17.1 psi. So if you had like a pressure gauge hooked up over here, it would likely be measuring the gauge pressure, which would be calibrated that way. And that would be done so that the variation in the atmospheric pressure over this height is negligibly small. And the gauge pressure would simply be telling you how much pressure is being built up in this tank compared to what it is outside. And that's it for example number 5, and our differences between gauge pressure and absolute pressure.